Next.
I'm Mustafa Hassanyan.
Okay, next.
I'm Christina Fitziak.
Okay, next.
I'm Catherine Chalikas.
Okay, next.
I'm Brady Quinn.
All right, and then lastly.
I'm Emma Adakauskas.
All right, let's start. So, have you ever looked at the sky and asked yourself, how does an airplane move so fast for being so massive, and how does it stay in the air for such a long period of time? Well, the basic answer is that it's powered by multiple twin turbojet engines. But for this speech, I'm going to be diving in deeper on how a turbojet engine actually works. So first and foremost, you need to understand the basic physics behind this, which is based off of Newton's third law of motion, that for every action there is an equal but opposite reaction. So how does this apply to turbojets? Well, when an engine expels hot gas backwards at a high speed this way, that force allows the plane to propel this way. So in terms of the stages of operation for how a twin jet actually works, there are four key terms you need to know. This is the intake, the compression, the combustion, and the exhaust. Now, of course, there are other key features that I'll get into later on in this speech, but transitioning into the first stage of operation, the intake, it's as simple as it sounds. When a plane moves forward, large amounts of air go into the engine's intake system. And if you've seen a jet engine before, you know it has multiple um, fan blades. And when air passes through these fan blades, it becomes compressed. So into the next stage called compression, this is when the air pressure increases and more importantly, the air temperature increases. So why is it important that the air temperature is high? Well, for the combustion phase, you want the jet fuel to be mixed in with this compressed air at a high temperature, and that causes ignition in the combustion chamber. Now, like cars with an airplane engine, this hot gas and hot air needs to be diverted some way, and that's called through the exhaust system. Now, as the hot gas expands, this gets expelled through various nozzles at high speeds, which generates thrust, and this gas uses force from the gas to spin a turbine, which allows for a continuous cycle. So when you see how a plane engine can stay moving for 10 to 15 to 20 hours at a time, it's because of that continuous turbine cycle. And of course, there are other key features that I mentioned earlier. This includes the afterburners, which is when you inject additional fuel to get a boost of thrust, which is more common in military style planes, not necessarily commercial aircraft that we see every day. Then, of course, there is minimal moving parts. So a jet engine relies on continuous airflow, not like a car that has all sorts of moving parts. And this is actually safer because it lowers the risk of mechanical failure. And then, of course, the third and my favorite aspect is the thrust vectoring potential. What this does is jet engines can actually adjust their exhaust direction. So, from a pilot's perspective, that makes it actually easier to maneuver the plane and fly the plane. So, in conclusion, turbojet engines are crucial for high speed aviation as they offer immense thrust and immense performance. They're very efficient and economically stable, making air travel more efficient for everyday use for people like you and me. Thank you.